The last lecture for today, for the second week of the MPP Calculus class, is a quick lecture that talks about taking derivatives of exponential and logarithmic functions. This will mostly consist of rules followed by a few examples. The very first rule is that if you are interested in taking the derivative of the function e raised to the x, the good news is the derivative is e raised to the x. In a nutshell, you now understand why economists use e to the x frequently. If they can take a natural phenomenon and represent it as something like e to the x, what it lets them do is repeatedly take derivatives. So you know that you can take not only the first derivative, but the second and the third and the fourth and the fifth, which in more advanced applications is very, very useful. So that's the first rule. So e to the x is an exponential function, and this is a more general form of, the more general form of the rule for exponential functions is that any constant raised to the power x, its derivative is going to be that constant raised to the x times the natural log of a. So you'll see that this specific rule for the exponential with the base of e works out for a more general form because, of course, the natural log of e is equal to 1. You'll also very frequently see a need to take the derivative of an exponential where you have a function of x in the exponent. The good news is that the chain rule still works. So what you can do is take the derivative of the first, a to the f of x, ln of a, times the derivative of f of x. So let's just do a few examples of that particular problem. If we have a function, say f of x, that's equal to e to the 2x power, the derivative f prime of x is going to be equal to that same problem, e raised to the 2x times the natural log of e is 1, times the derivative of the exponent, which is just 2. In other words, you have 2e to the 2x. If you have a function where you have e to the x squared, the derivative of that function will be e to the x squared times ln of e, which is 1, times the derivative of x squared, which is 2x, or just 2x e to the x squared. Notice here that the x squared is only, the power is only applying to the e. The 2x is not raised to any power. All right, so here are 3 examples for you to try out of exponential functions. Go ahead and take their derivatives. You might pause the video now, and then I'll come back and walk you through. All right, so for the first example, we have that the derivative of g with respect to x is going to be equal to e to the square root of x times the derivative of the square root of x, which is 1/2 x to the negative 1/2. If we want to be nice about it, we would write e root x over 2 root x. For this second term, we now have a case where we need to apply the chain rule. So h prime, the derivative of h with respect to x, is going to be equal to 1/2 times 1 minus e to the x to the negative 1/2 power times the derivative of this term inside. The derivative of 1 is 0. The derivative of negative e to the x is negative e to the x. So if we finally simplify that out a little bit, we get negative e to the x over 2 times the square root of 1 minus e to the x. Finally, for this last one, we'll need to apply the product rule. So we have the derivative of f with respect to x. We take the derivative of the first term, which is just 1, times the second term unchanged, plus the first term unchanged times the derivative of the second. So now I'm going to be a little bit careful and think this through. The derivative for this second term is going to be equal to e to the negative x squared times the derivative of negative x squared. So that would be negative 2x. And notice that I'm being very careful about my parentheses here, just so that I don't lose anything. So if I multiply that out, I get that that's equal to e to the negative x squared minus 2x squared e to the negative x squared. So that basically covers dealing with exponential functions. Now we'll talk about dealing with logarithmic functions. I just want to take a minute to remind you of the definition of the logarithm, that the logarithm is the inverse of the exponential. So if you have a statement y equals e to the x, the way that you get the x by itself is that you take the natural log of both sides, and the natural log of e is 1. You bring the x down as the coefficient in the front, so that the logarithm is equal to of a number is equal to the power that you would have to raise the base to. Now, if we want to, we can think about other exponential functions that are not base e, and then we simply have the log of whatever, with whatever base we had, of y is equal to x. So with that introduction, let's go ahead and look at the derivatives of logarithmic functions. The derivative with respect to x of the natural log of x is equal to 1 over x. If you have a non-logarithm, or sorry, not the natural log, so a base other than e, the derivative of a log base a of x is equal to 1 over x times the natural log of a. Now, we won't go through the process of deriving these limits. These limits grow out of some theories about how you take the limit of an inverse function. So remember, we know how to take the derivative of an exponential function, and there's some theorems about how you take the derivatives of inverse functions that get us to this result. To be perfectly honest, for Harris purposes, you simply need to memorize this. Just memorize it. You know, to be honest, you're less likely to see a logarithm like this, but you might run into it. So those are the two basic rules for logarithms, for taking the derivatives of logarithms. The good news, just like with exponential functions, the chain rule works exactly the same way as it did before. So now if you have the natural log of a function, the way that you find the derivative is you take 1 over that function times the derivative of that function with respect to x. So just to go through a quick example, we might have a function g of x that's equal to the square root of the natural log of x. Now notice here, this is kind of the reverse setup is what I just talked about. You're going to apply the chain rule in the opposite order. So if you wrote this as a composite function, you might break it into u of y is equal to the square root of y, and v of x is equal to the natural log of x. The derivative of u of y is equal to 1/2 y to the negative 1/2, and the derivative of v with respect to x is equal to 1 over x. So taking the composite function, the derivative of g of x is going to be the derivative of u, which is 1/2, and here we're plugging in the natural log of x for y, raised to the negative 1/2 power, times the derivative of v, which was 1 over x, which we can rewrite as 1 over 2x ln x, square rooted. So here's a more complicated example. Why don't you go ahead and pause the video and try it out on your own. All right, so we'll break this into several different pieces. I'm going to rewrite this as the natural log of x plus 1 quantity times x minus 2 to the negative 1/2. I'm going to take the derivative of this inside piece first. I'm going to say, well, I can use my product rule. I'll take the derivative of the first, which is just 1, times the second unchanged, plus the first unchanged, times the derivative of the second. And I'm going to pay careful attention to the negative sign here. That's negative 1/2 times x minus 2 to the negative 3/2. Notice I need to check what's in here, but its derivative is 1, so I don't need to apply the chain rule another time. So now I have the derivative of the term inside the parentheses. So now what's left to do is apply this logarithmic form of the chain rule. I get that the derivative of f with respect to x is equal to the reciprocal of f of x. So if I look, and don't let the f of x confuse you here, right? Like this is the f of x inside of the logarithm. So I need to take the reciprocal of this fraction. I get the square root of x minus 2 over x plus 1 times this derivative that I just calculated. And I'm going to notice that this x minus 2 to the negative 1/2, I can actually factor it out. And since it's on the bottom, that will be the square root of x minus 2. On the top, I have 1 minus 1/2 times x plus 1 times x minus 2 to the negative 1 power. There are a lot of similar terms here, so I need to go ahead and keep simplifying. Notice that my x minus 2 square rooted cancel one another out. I also notice that I have this obnoxious x minus 2 to the negative 1 term, and I want to bring it down into the bottom. So in order to do that, I need to multiply through x minus 2 with this first term. So I get x minus 2 on the top minus 1/2 times x plus 1 over x plus 1 times x minus 2. Go ahead and pause the video if you need to follow through the steps that I just did, because I did a number of steps all at once. And then the final simplification step, I can multiply everything through. I'm kind of annoyed by this 1/2 here, so I'm going to move it into the bottom. And to do that, I need to multiply that by 2. So now I multiply things out. I get 2x minus x is just equal to x. I get negative 4 minus 1 is negative 5 over 2 times x plus 1 times x minus 2. So there are a few other acceptable ways to have simplified that, but that's probably the best final simplified form. All right, final two examples for you to try out. Pause the video and then come back and I'll walk you through. All right, so here we're going to apply the chain rule for logarithms. We're going to say, look at the derivative of the inside term. The derivative is just 2x. So the derivative of the full function is going to be 1 over the term inside of the logarithm, x squared minus 1, times the derivative in the logarithm, which was 2x, or just to rewrite it a little more cleanly, 2x over x squared minus 1. For this other, we need to basically do the chain rule version of the non-natural logarithm form. So what we do is, again, we take the derivative of this inside term. It's negative 2x. We look at how you take the derivative of base other than natural log, and you see that it is 1. So the derivative here is going to be 1 over the term in the logarithm, 1 minus x squared, times the natural log of the base. And now, because it's the chain rule, we need to multiply it by the derivative of the item inside the logarithm. So that's times negative 2x, or just writing it a little more cleanly, negative 2x over the natural log of 3 times 1 minus x squared. And with that, we finish the lectures for the second week of the MPP math class. There is an online quiz for you to take, and after class, there are also practice problems for you to work on if you would like additional practice with these concepts. Look forward to seeing you in class.